Hey, good morning guys. Today I'm going to talk to you about the elements. We've been talking about water and the atmosphere and humidity, things like that. But what is water? Water is made out of elements, and elements are small particles. There are about 118 of these known elements that we've discovered, and we're learning more about them all the time. Every year we come up with new discoveries about these elements, and sometimes we discover elements that we hadn't known about before. Really interesting stuff. So let's find out what an element is. An element is the smallest particles of matter. So the concept of an element goes like this. I can have this lump of Play-Doh. Let's say this is matter. It's something that takes up space and it has mass, all right? If I have this lump of Play-Doh and I cut it in half, then I have two lumps of Play-Doh. It's still Play-Doh though. If I cut that piece in half again, and then cut it in half again, and then cut it in half again, and again, and again, and again, and again, and again, eventually I get down to a part that is still Play-Doh, and if I cut it any more, then it's not Play-Doh anymore. So at what point does it become not Play-Doh? And that is the edge, that's the threshold of what determines whether something is an element or not. An atom is the smallest particle of an element. An atom is the smallest particle of an element. Now if we take more than one atom and put them together, now we have a molecule. A common molecule in our atmosphere is oxygen. Two atoms of oxygen stuck together make a molecule of oxygen, and that's floating around. That's the stuff we like to breathe. Let's figure out how to make a molecule of water. I get my cookbook out and figure out a recipe for making water. It looks like for water I need 2 atoms of hydrogen and 1 atom of oxygen. So let's go see if we have that in the cupboard. Okay, spices. Oh, here we go. We have some oxygen atoms. We've got some hydrogen atoms. And these are electron bonds. We'll talk about these a little later. So now if I take those oxygen molecules and I heat them up on the stove, put them in a pot of water and turn on the fire, a fire is adding thermal energy. Heat energy is transferring from the gas in the flame to the water molecules that are in the water, and they are starting to move around more and more. When they're in the liquid state, the molecules are kind of moving a little bit, but they're not moving very excitedly. As we add thermal energy, they move more and more, and they get very fast, and eventually as they get so fast, the top layer of them starts to evaporate, and that's where it turns into water vapor, which we know as a gas. I want you to try this simulation. The simulation is one where you are going to set the beginning as having water, and then set the beginning to having liquid, and then turn up the heat. Drag that slider and add heat to your liquid water and see what happens to the molecules. You notice they're starting to wiggle around, and as they get hotter and hotter, eventually they are turning into a gas, water vapor. Try it again in the other direction, starting out with water, starting out with it in a gaseous state, and then this is what we see when we have water vapor in the atmosphere. You chill it, take the temperature slider and make it colder and colder, and as it gets colder, those water molecules move less and less, they come closer together, and they condense and form water droplets. So if a molecule of water is 2 parts hydrogen and 1 part oxygen, then how much is in a drop of water? A drop of water is actually going to have 1.5 sextillion molecules of water. That's not even atoms, that's molecules. That's the 3 together. 1.5 sextillion. And that is a 1 with 21 zeros after it. That's huge. but they're so small you can't see them, and you definitely can't see them until you have a lot of those together. All right, that's it for today, guys. Explore these links about some atoms, molecules, water, and energy. Have a great day.